Donc bonsoir à tous. Donc effectivement, je suis Marielle Brunette, chercheur INRAE en économie à Nancy. Et j'ai ce soir la chance de présenter Marc Hanewinkel, donc qui est un collègue à moi depuis pas mal d'années et un ami aussi finalement. Donc Marc on s'est rencontrés quand j'étais en thèse et donc c'était un des membres de mon jury de thèse. Donc autant vous dire que ça fait pas mal d'années qu'on se connaît. Et oula, il se passe des trucs bizarres. Il devient tout petit. Bon, est-ce qu'il m'entend? C'est surtout ça.
Oui, je t'entends toujours.
Ok, on m'entend toujours. Bon, soit.
Je vais partir là.
Wow. Ah non, c'est bon, je crois que c'est résolu. Ouais. Ouais, c'est ça. C'est l'effet jury de thèse, il n'a pas aimé. Oui, ça marche, c'est bon? Ah. Et si je parle là? Non? Ok. Après, je peux garder le micro, je pense que ça fonctionne. Mais...
Non, j'entends tout. Là,
ok,
ici.
ça marche. Bon, du coup, effectivement, donc, comme je le disais, on se connaît depuis pas mal d'années avec Marc. Et donc, on a eu la chance de collaborer sur un certain nombre de projets. On a écrit quelques articles également ensemble. Et donc, Marc est professeur à l'université de Freiburg, en Allemagne. Et il est titulaire d'une chaire en économie forestière et aménagement forestier. Donc, il travaille sur des sujets assez variés autour de la thématique forestière, notamment un sujet qui nous est commun à tous les deux, donc la notion de risque. Donc, il a travaillé beaucoup sur tout ce qui est impact des risques, quantification des risques, décision en présence de risques, et notamment, on a travaillé beaucoup ensemble sur l'assurance des risques naturels en forêt. Donc évidemment, il a publié beaucoup sur l'ensemble de ces thématiques. Alors là, j'ai parlé du risque, mais il a aussi fait beaucoup de choses sur les services écosystémiques, sur la modélisation économique et écologique. Voilà, je ne vais pas brasser tous les sujets, mais voilà, il a travaillé sur beaucoup de thématiques forestières. Et du coup, il a énormément publié sur l'ensemble de ces sujets-là, dans plus d'une centaine d'articles, dont certains dans des revues assez prestigieuses comme Nature ou PLOS ONE. Il a aussi coordonné un certain nombre de projets nationaux et internationaux, notamment un projet européen, donc sur la période 2011-2015, qui s'appelait Motive. Donc ça doit parler à certains d'entre vous, sur la modélisation de la gestion forestière adaptative. Donc Marc est francophone, donc il a aussi une certaine relation avec les instances françaises. Donc il a été membre, par exemple, du conseil scientifique de l'ONF et il est actuellement correspondant associé à l'Académie d'agriculture. Et depuis cette année, donc même récemment, là, il y a quelques mois, Marc coordonne avec d'autres collègues un projet qui s'appelle Future Forest, qui est un peu l'équivalent de notre PEPR FORESTT, mais version allemande. Et donc, du coup, on a trouvé que ce serait intéressant de l'inviter à parler aujourd'hui à la fois de ses travaux et puis de cette ouverture sur ce projet qui est un peu voilà, la version PEPR FORESTT en Allemagne. Donc, merci Marc d'avoir accepté notre invitation et puis je te laisse la parole.
Marielle, merci beaucoup. Bonjour, bonsoir à tous et à toutes. Désolé de ne pas être avec vous en personnel, de donner cette intervention en distanciel. J'essaie de partager mon écran maintenant. Donc ça se voit?
Oui.
Vous le voyez?
Ça marche plus. J'ai plus de micro.
Oui?
Il est branché mon micro. Oui, non.
Alors vous voyez mon écran?
J'ai plus de micro. Ah oui, on le voit. C'est parfait.
D'accord. Et on m'entend?
Oui, tout est bien.
Okay. So thanks a lot. Again, I will switch to English from now on. Otherwise, it would take quite long to translate all that in French online. Thanks again for this opportunity to present, well, first, a bit of a glimpse of what I have been doing in the past years. And the second one, and I think this is probably the most important, I will very briefly present our cluster of excellence that is called Future Forest. So that is a bit the plan, what I have. I will very briefly cast some lights on some topics I have been dealing with in the past years. The first one is economic impacts of climate change, notably of tree species shifts in Europe. So this is a bit to present the general approach that we are using at my chair. The second one is a bit a specific topic that is based on a research training school that we have in the past 9 years, that was dealing with the impact of biodiversity management. And I have been covering the economic part on that, especially the economic part under uncertainty. So we wanted to develop rather robust and deterministic management strategies. And the third one is a totally different topic. We had quite a strong impact, a strong focus on looking into climate change impacts on tropical and subtropical forest productivity in Central America, mostly Costa Rica and Panama, and looked into impacts on ecosystem services. And then the last part, and hopefully after 20-25 minutes I will reach to that, that would be the very brief introduction into our cluster of excellence that is called Future Forests, so adaptive, complex, social ecological forest systems to global change. So that is a bit the plan. I hope not to exceed too much my 30 to 35 minutes, then in case, please apologize. Okay, I start with this first topic, economics of tree species shifts under climate change. You might probably have seen this type of species distribution modeling. This one is here, is for the main economic species in Europe, Pessia abies, Epicea, one of the most, let's say, interesting species for industry. And what we did was, is based, when you see these black dots, that's a large scale monitoring plot system, ICP level 1, and my colleague Niklas Zimmermann, I've been working at WSL, where he still is active, has set up a large species distribution model, biome shift model for major tree species in Europe. And when you look into that, so that would be based on this large-scale monitoring system, sort of an idea how could we expect this species under the current climate when we use, let's say, main predictors based on precipitation and temperature, and the combination of them, drought indices, and you see the highest probabilities of looking at this species or finding a species would be around the Alps in the higher mountains, but mostly also concentrated in Scandinavia. And now we applied climate scenarios so that you know the game here. So we basically put the heat on, we reduce the precipitation. We looked at quite strong warming scenario from the fourth assessment report at the time being A1FI. And you see what happens to the species. You can follow that. That would be A1FI 2040, this 2070, and this 2100. And what you see here is that the species would more or less totally disappear from Central Europe, would move far north to Scandinavia, very north of Finland, Sweden, and Norway, and a very small population in the higher Alps. We even don't know whether this is realistic. The bad thing about that is the bad news. That is why I was interested in the economics behind that. How does that change the productivity of European forests? And what we did was we grouped basically all the species that we found in this monitoring data set into 7 groups, reaching from the most abundant broadleaves like European beech. Then we had the oak species. Then we had Scots pine. Then our spruce that I've shown you. But we also had birch as a very cold and wet adapted species. And then we had, and this is what you see, maybe do you see my mouse here also? Yes? Do you see in the very southern part of Europe, around the Mediterranean, we also would observe 2 Mediterranean species. We group them, so these are not single species, these are groups of species with similar ecological behavior. So you would see that, and that is a potential distribution based on the current climate, 1950 to 2000. So we would expect in the northern part of Scandinavia, as I showed you in my first slide, mostly Novus spruce being dominated around the Alps, around the Carpathians. When you look into France, we would have these Quercus robur, Quercus petrea. See, interestingly, it's quite a fine scale. We had 700 times 700 meter pixels. We even see this distribution of maritime pine that is part of the productive pine group. in southwestern France, in Leland. I mean, this is a model, this is not reality, but anyway. But what we also see is that very south here, we have already today drought and heat adapted species like holm oak, cork oak, and we have Mediterranean pines. The one that is dominating here is Pinus halepensis. So this is one observation here from the current line. There's a seventh one. Here is already an economic thinking behind, because for each of these small pixels of about 50 hectares in the whole of Europe, so we are talking here about roughly 150, 200 million hectares of forest, we always calculated the probability that a species would be there or not, and if the species would be there or not according to a predefined threshold, we always choose the most economic species, if possible. And if the species like Novi spruce, that is the most economic, is not possible anymore, then we switched to the next one. And then if this one is not possible anymore, we switch to the next one. So this gives us this, let's say, potential distribution of tree species, also including some economic thinking. And you see, for example, in Germany, most parts of Germany would be here covered by European beech. This is indeed a natural distribution spectrum. And then we did the same exercise that I've shown you in this species distribution modeling slide. We applied a climate scenario. In this case, the very tough scenario, A1FI, and watch out for these small pictures of these different tree species groups. So when the picture gets bigger, the share of the potential species will increase, and if it gets smaller, it will decrease. And this is, I'm only showing you this extreme scenario here, A1FI 2100, let's say plus 5 to 6 degrees Celsius more under 2100, and that would be the dramatic change we would observe in Europe. So 60% of the European space only covered by these Mediterranean oak species. Even these Mediterranean pine species would disappear, they wouldn't be able to survive. There would be some, as I told you in the first slide, there would be some spruce remaining in the very north. The productive oaks would still be there, but very much translocated to the Scandinavian part, also northern part of the British Isles, some very small remnants of the productive pine species, and beech more or less extincted. That is quite a dramatic change. We published a paper in Nature Climate Change in 2013. I was thinking at one point I have to stop to show this because it's being outdated. It is not. When we look at the last years, the dramatic change that we see, especially in the loss of productive coniferous species, we must admit that the change is probably even much faster than we had it in the model there. Just a very brief summary. So we have a decline of the productive species like Novi spruce, of the productive oak species that is staying on a certain level, productive pines, and we would have seen these very prominent increase of Mediterranean species. Watch out for these arrows. They only depict one part of the uncertainty that is behind that here. So this is the climate uncertainty that is quite prominent, especially with beech. So when you apply different realizations of climate scenarios, you will get different results in the end. So there's quite some high uncertainty. We combine that then with a very classical economic approach. We calculated the land expectation value of each of these species groups. And what we found is that there is quite a harsh decline of these land expectation values. So the left column is we calculated in price calculations of 2010, about 3,500 euros. And this goes down in the mean in the year 2100 here for a mean scenario to, let's say, 2,500 euros. So this would be in the mean, let's say, 1,000 euros per hectare of loss of productivity. And if you upscale this to this whole forest area, 200 million hectares, we calculated multiplied with 1,000, we get losses of about 200 billion euro. Again, like the first extreme picture that I showed you, this was of course criticized, saying, okay, there is large uncertainty. Yes, that is true. There's a major uncertainty, mostly related to the prices and the cost, the interest rates. Here we chose an interest rate of 2%. We made, of course, a variance analysis. What happens if the interest rate changes? There is not much. It's just the standard that we observe. So the interest rate rises, it decreases. And if the interest rate goes down, it increases, because this is a sort of a net present value. Still, these 200 billion euros in losses, that sound a lot, it is not, it is very little. So this is a paper that we published in a very practical oriented journal in 2021, that is why it's in German. Only in Germany, in the years 2018 to 2021, we calculated a damage caused by the immense drought and consecutive insect attacks of roughly 13 billion euros on an area of maybe 5% of the area that I have shown you here. So we have to assume that when we calculate this type of damage due to climate change, we usually underestimate the damage, because we are never able to capture this type of uncertainty really well. So this for the first part. The second part is a totally different story. So this is here we look into the biodiversity-oriented management under uncertainty. And we were looking into conservation costs of retention forestry and into the possibility, or the necessity rather, of the change of these conservation practices. This is based on the following slides. The following results are based on 4 PhD studies that I supervised in the last 5 years. The first one was by Andrei Augustinczyk. These are all paper-based PhD. So Andrei was quite productive. He handed in 6 published papers, which is not the standard. It was within what we call a research training group that is called CONFOBI, Conservation of Forest Biodiversity in Multiple Landscapes of Central Europe. What we did was here is, our approach was here, we combined a process-based growth model with an economic approach to study what are the impacts of a biodiversity-oriented management. So the first approach we did, first of all, what did we add to what I have shown you in my first slides? We added, let's say, quite a deep analysis, an intensive analysis of several uncertainties. So the first approach I showed you, we were rather looking into the climate uncertainty as a result of using different climate scenarios and different realizations climate scenarios. Here, we also looked into the parameter uncertainty of the process-based model, in this case 3PG, that we used, and we looked into economic uncertainty. So what we did was we standardly produced probability density functions here as a function of the land expectation value again, and then we looked into the outcome. And what you see here is there's different, these violin graphs show you about the size of these different uncertainties. So the overall uncertainty, this is what depicted in this graph here. Then we have this model uncertainty related to the multitude of parameters. If you change them, you will get, of course, different results. Then the price uncertainty is rather narrow. Prices change, are volatile, but not to a large extent. What is really very prominent in this uncertainty is when you choose different interest rates that will very much influence the outcomes. Now, looking at these types of uncertainties, we created, let's say, a first study on a model landscape. Again, this was also in the Black Forest. That's a real landscape, but we, of course, set up sort of an idealistic system of let's say, retention areas. So the dark green are existing forest reserves. the rather here, this color, these would be new forest reserves that we implemented. And now here, the task was to connect these existing forest reserves with a series of deadwood islands and optimize that. In a deterministic solution, you see that is based on graph theory. You have to find the optimal distance between these plots, these deadwood islands, in order to, let's say, optimize the conservation of one of these iconic protected species, in this case, a saproxilic beetle species. And you see that looks quite nice. The losses in NPV, net present value, are not really very important, and that was for us the most important in that study. If you add an uncertainty here, if you want to go away from a rather deterministic more to a robust management strategy. A robust management strategy is when you look back into these probability density functions that can also handle worst case scenarios. Worst case scenarios meaning that we go to the very far left part of these probability density functions and we look into the, let's say, 5% worst case scenarios and say, okay, under which management strategies would be able also to deal with those. And there you see that the picture is totally different. So we would need much more of these deadwood islands because we systematically lose them due to the different uncertainties, and they would be totally differently distributed in the landscape. The same with the management strategies that are behind that. So the optimal portfolio for a certain area of management strategies, we looked into 2 selection forest strategies and 2 even age management strategies. You see here in the deterministic case, one of these uneven age management strategies would very much dominate the landscape. The black one would be no management strategies that we would need in this landscape to protect this beetle. But if you change to the robust case here again, we would need a totally different, a much more diverse distribution of these management strategies. And that was probably the most important here, we would need much more of these no management strategies because in the other plots, in the management, we lose too much of the interesting, let's say, deadwood parts of the population. So that was the first part. The second part is what I would like to show you, or the third part of my talk is we had indeed one emphasis on looking into tropical, mostly plantations in Central America. This was a project that was funded by the German Environmental Foundation and the German Research Foundation, and 3 PhDs came out of that. So we first looked into process-based modeling of mixed species plantations. Then we looked into impacts of climate change on the productivity of these mixed plantations, and then also into the economics of these mixed plantations. We did this together with green investment funds in Germany. And the last one, this is a different PhD, we looked into also impacts of species shifts and on ecosystem services. So the first one, this is a paper that we published in Science Advances 2 years ago by Anja Nolte. So this is a setting here. We were investigating quite a bit on mixed species plantations that these investment funds had created in mostly Panama and Costa Rica, in these mostly in these 2 countries. There were 5 species included, 1 foreign species, Tectona grandis, teak, sort of a cash cow in this, let's say, framework of plantation forestry. But there were also 4, let's say, indigenous species. And the interesting thing here in these type of plantations is there is a mixture of fast-growing pioneer species like Voitschisia, guatemalensis, and very shade-tolerant high but slow-growing species like Dalbergia retusa is also known as rosewood. And in between Dipteryx oleifera, that is a species that is named there as almendro. That is interesting also for biodiversity. It's a tonka bean because there is protected birds feeding on it like parrots. And we looked into what happened to the productivity of these plantations under climate change. And what was quite astonishing for us is that even under these tropical, subtropical conditions, we observed in our process-based modeling a sharp decline of the future productivity under a certain temperature threshold. This temperature threshold was about 29 degrees, about 29 degrees mean temperature. That sounds quite a lot, but if you look into one of the climate scenarios, we observe the SSPs in this case, so larger parts of this area would be subject to this type of temperature change. Interestingly, there was a Nature paper basically published a bit before we came out with this paper, more or less coming to the same results on a larger, of course, on a much larger database. The second one we did was, and this is the PhD of Anja Nöltes, so this was the third paper of her PhD. We did then, in a second PhD within this project, an economic valuation of these plantations, because these investment companies that were interested in looking, well, is there any economic return to be expected? They were also interested in, can we change the management strategy from this classical clear cutting of the plantations to rather uneven aged long-term sustainability strategies. We looked a bit more in detail on two of these plantations in Costa Rica, Las Delicias and La Virgen, rather close to, in the northern part of, northwestern part of Costa Rica, close to Nicaragua. You see the climate. The climate there is, first of all, these are rather lowland plantations, not up in the mountains. Second, they have both a rather prominent dry period there, so it's not entirely tropical. It rains a lot, but especially in spring, in our spring, there's a dry season. Second, you see that the temperature, the min and the max, they range between 20 and 30, 35 degrees. Now, just one result, we did a very classical economic analysis where we looked into how much carbon can be accumulated. This is of increasing interest in these plantations because many of them are now run under carbon certification standards. But we also looked into a standard, a classical economic parameter, the net present value. And this is a typical Pareto frontier analysis or productivity possibility frontier. And what you see here is when you look along these frontiers, what you shouldn't do in these plantations is only use and plant these slow-growing shade-tolerant species, or even the one that, let's say, tolerates some shade, or here even only a mixture of these two. Yeah, so you will go by nowhere in that. The second, what was astonishing for us, the cash cow teak, Tectona grandis, in the monoculture didn't perform very well, especially in both, not in net present value and mean stand carbon. Along here, this analysis is mostly along the different rotation times. You will need to take these teak quite early, after, let's say, 15 years, 20 years. But what's interesting for us is that, and when you look at the upper part here, these are all mixtures. And the more admixed species, the better is the performance. Of course, the net present value goes down. The longer you wait, the more carbon you accumulate. But this is something in the preference structure of these investors. This is something that they would tolerate for themselves. So this is the second study that we did in this area. The third one is, that was the PhD of Arne Pinschmidt, basically dealing with economic aspects. The third one is a study that we did that was funded by the German Research Foundation, rather basic research. We looked into a higher level, in this case not forest stands, but rather plant functional types that Lukas Baumbach modeled in his PhD, and we made projection what happens to these different plant functional types, so groups of, let's say, tree species that are generalized by their behavior. Are they rather generalists? Are they specialists? Are they rather under dry conditions? Are they conservative? Are they rather expanding, acquisitive? And what we found in these projections under climate change is there are some, and he looked into a larger range, so basically reaching from Mexico until Colombia in this whole isthmus of Central America. And he found, first of all, that there are apparently hotspots for this type of transition in the central region of the area we observed. What he also found is that there are species, plant functional types that are profiting from climate change. These are rather the generalists, but those who are really largely going down are the specialists, and this is mostly the montane species. This is mostly those that are wet adapted, conservative, and the conifers that are still there, but that would go down. Two maybe major results of this study. First of all, what we observed here are two phenomena. First of all, here you see an analysis along a latitude and altitude gradient here for two of these species groups. And what we first observed is a sort of a loss of habitat connectivity. You see that in these gray areas. So under climate change, they basically lose the connectivity, which is a problem because we then have isolated populations, especially also for the biodiversity that are related to these plant functional types. They cannot basically connect anymore. The second one that is also quite prominent is for the conifers and the montane species. What we see here is an upslope shift and a risk of a mountaintop extinction here. So they move up. You see that in these gray areas. These are the habitats that are not suitable anymore, and then they're trying to move up, and at one point they have no space to move up again, and then they die out. And the last, this was the second paper, the first paper of Lukas Baumbach's PhD, and the second paper was indeed an economic analysis that we did then, but using not these plant functional types shift modeling, but we indeed then adapted a dynamic vegetation model, in this case LBJ gas, and we looked into the ecosystem dynamics, and then we made an economic valuation of the loss of biome stability and of the loss of carbon. And we looked into, let's say, present studies. We did a benefit transfer, as this is called, and we basically made a meta-analysis of all available studies for this area or similar areas. And we made a projection until 2100, and we looked how much of the biome stability is being lost and what does that mean in terms of economic costs that are involved. Just a very quick glimpse on that. So we have quite a prominent loss here in the more drier forest regions. The losses can be heavy until $4,000 US dollars per year and hectare. And here we are talking about a forest area of 80 to 100 million hectares. So the losses also go into the hundreds of billions of dollars that we calculated here. What's a bit astonishing is that stronger climate forcing didn't really increase the area affected, rather decrease it, but the loss still were, again, rather high. Okay, so far for a very short introduction into what I did the last years, and then for the last, I would say 10 minutes, I will give you a very short introduction into our cluster of excellence, future forest, maybe some basic data. So the title is Adapting Complex Social Ecological Forest Systems to Global Change. There's 3 coordinators, the spokesperson, Jürgen Bauhaus, and 2 co-speakers. Jürgen Bauhaus is a well-known silviculturist, highly cited researcher. Friederike Lang is a soil scientist from our faculty, and myself, I'm more or less representing, let's say, the social science, the economic part, also partly the modeling part of that. The start is due 1st of January 2026. It is meant for 7 years. I think you suffered the same budget cuts that we did. We were originally planning with almost 60 million euros. Then, well, we've been told, no, we have to reduce by almost 25%. That would have been far less than 50 million, 45 million. Now we found some private money through a big foundation. Now we are back into, I would say, more than 50, rather 55 million, 52, 53 million euros, which is an enormous sum. We have the opportunity to apply for a second phase of this cluster for another 7 years in 2033 with the same amount of money, hopefully, probably again with the same cuts. What is maybe different to your cluster Forestry in France is we are not talking about a multitude of university or hundreds of researchers, I don't know. This is basically run the whole cluster by 25 principal investigators and about the same amount of associate investigators. And what is probably also a large difference to your cluster, from these, it is only one university that has applied for this cluster and also was granted the cluster. And from these 25 PIs, 90% are indeed from this one university. We have added some selected researchers from the Stockholm Resilience Center and from the Forest Research Institute of Baden-Württemberg. And also what is also quite specific, from these 25 PIs, 80% come from one faculty. So my Faculty of Environment and Natural Resources. I'm not going to bore you with this type of visions. I think you also had to come up with this, oh yeah, we want to be world leaders, we will deliver science that is important for society, we will have a new generation. You know that, you need to deliver that, otherwise you will not get anything. I'd rather get into a specific thing in this cluster. Our research area, and that was a bit of a risk, is not the globe, is also not Europe. We really want to concentrate on a forest area, a large forest area in the southwestern part of Germany. So we're talking about the Black Forest and the adjacent Rhine Valley lowlands. So the Black Forest is about 500,000 hectares. The Rhine Valley, you know the two, it stretches into France, and this is one of the climate hotspots, not only in Germany, but we could also say in Europe. So we suffer there really a loss of forest. We don't know exactly what will replace it. We see extreme measures to keep some forest there alive by irrigating that, which is unequaled before in Germany, mostly to keep some oak populations there. We work on different scales, so from the cell, the single tree, up to the landscape. And what our plan is that indeed we will define several case studies, larger case studies, 30 to 50,000 hectares. We call them social ecological systems case studies because we will get them in an intensive dialogue with stakeholders. They will be distributed in these both landscapes, in the Black Forest and in the lowlands. And in between there we'll do the research. The final research design will be fixed in the next weeks. We have, of course, concrete ideas, but we will have to be concrete there. We would try to set up a global a global context here by using all our networks. I will come to that later at the end of my talk. I will very briefly now represent you, because I'm already a bit advanced in time, the organization without any methodological details. So the cluster is distributed in 3 research areas. The first one is on risks and adaptation options. The second one is a pure social science research area, decision making. And the third one tries to integrate it and develop adaptation and transformation pathways for novel forest socio-ecological system. We have some central facilities in the cluster. Of course, we need research data management. We want to install a future forest academy to mostly take care of early career researchers. We have an international forest adaptation lab. This is to set the links to other research communities worldwide. And we have 2 modeling labs. The one that integrates all the modeling activity, and then the other one that is this SES case lab that I've been mentioning already. Quite briefly, what are the different research areas about? The first one is to risks, to ecosystem adaptation options. So we look into impacts, into responses, into controls. We looked at the theory behind that, as we look into forests as complex adaptive systems. Very briefly, so we divided these research areas into research themes. Research area A is most probably the most comprehensive. It has 5 of these themes, reaching from environmental control. This is where most of the empirical work will be done. There's a strong impact of the hydrologies, water as a central resource. We then really go down to the hollow beyond, to also the single cell. We do genetic research in A2, looking into, is there a biological adaptation? Then these A3 is very much into the different risks and how to handle these risks. Then 4 is biodiversity. What are the impacts of biodiversity? And 5, interestingly, we also integrated the medical faculty, and we want to look into the impacts on human health. So that very briefly, research area A. Research area B is about decision making. So we look into the evidentiary basis of decisions being made under uncertainty in this process of adaptation and transformation. We will look into principles of decision making. This is where I will be involved. For example, here I will look into one of the principles will be robustness, another one will be legitimacy, a second one justice. So under which principles can decisions being made, and then we go into the practices. So that is the research area B. And the C includes quite a strong modeling part, so reaching from the leaf basically to the whole biome, and from an hourly to a century timely resolution. We include socio-economic models, also a partial equilibrium market model will be included, but we also have physiological models, process-based growth models that we want to combine. So this is so we start with a theory on how should this SES framework look like, then under which scenarios do we run the models, and then we develop a model framework. This will not be one super model, it will be rather a combination of different partly already existing models, and then this will lead into governance, novel governance approaches. This is also part of this integrative research area. And then this will really supported by this modeling lab. And then at the end, we want to come up with these adaptation and transformation pathways for these SES. This is our graph that we came up in the end for the defense. It's even not part of the proposal. It looks a bit like intestines. So we look into different sustainable pathways, and we try to find, let's say, adaptation and transformation pathways that keep the system in a sustainable range. This is something that we really have to, again, also discuss and see how can we be more concrete on that. My last slide is, it was indeed quite a bit of a risk to say, hey, we concentrate on a large forest landscape in Central Europe, because everybody has international networks, and we are trying to include these international networks in our work in the cluster. You see these dots, this is where we all have partners, and we want to set up a sort of an institution here in our cluster, the International Forest Adaptation Lab. And of course, that is something, that is a point where a collaboration, for example, with the French cluster, but not only there, would be of very high interest to us. Okay, sorry for being later than foreseen. Thank you very much for your attention.
Thank you, Marc, for this very interesting presentation. I think that we have some question in the room. Il semblerait que tu étais très très clair.
C'est très tard déjà.
Oui, aussi.
Voilà.
Pas de réaction? Non, personne? Non. Oui, si. Ok.
Thank you. We're having problems with microphones here. Sorry about the delay. Thank you so much for your great presentation. And yes, there is a lot to discuss for sure, several hours at least. My question is about the opportunities for more collaborations between France and Germany and with these two clusters. Your last map raised an probably a relevant question for both projects, not only for the German one, but there is a nearly complete absence of tropical forest research in both of them. So it's not a reproach, obviously. I know that IFG and others are funding very important activities in the Amazon, but what about your cluster, and also what about the French cluster? Thank you.
Yeah. We deliberately decided not to open this to global research. We also have a lot of people working in the Amazon. Katrin here is doing research in Ecuador. We yourself are very active, or were very active in Central America. The risk of really, let's say, diluting the whole thing too much was for us too big. We have the clear goal that in the second phase that will hopefully be granted and in 7 years, we then have the clear goal to go abroad and also include then tropical forests. So this is an answer to the first question. We deliberately decided to really keep it now in an area where we have really a strong basis of data and methods, and it would have been too much to go global in the first phase. But the International Forest Adaptation Lab is one chance to include already people from outside, also from the tropics, and profit from at least the methodological approach that we do. The second one, I see a lot of connections to French questions. Remember that the Upper Rhine Valley is one of our core research areas. When you look into the Forêt de la Harte, for example, I mean, this is, you exactly have the same problems that we have. And I think this is where we really should see, not only there, but this is already a very strong point where I see even the necessity to work together. Because I mean, many things might be done in parallel, and why not looking into the different approaches and looking what can we do together here. I see clearly a necessity to collaborate there. Yes.
I have a question about your case study. Finally, do you forecast to have also a living lab, for example, in this area?
Yes, I think these SES case labs, yeah, they can be a synonym for living labs. We have right now a running project that is financed by the German Ministry of Research that is called a real lab, Reallabor Upper Rhine, that we want to integrate even in the cluster. Yeah, that would be at least one. But we also look into one, for example, in the Black Forest, many problems there occur due to the very split ownership in private forests. So there will be at least a second one. We are not only foresters dealing with that, with the stakeholders, we have anthropologists, cultural anthropologists, who have been working a lot in the Global South, and they also want to apply their methods. This runs under the name of research in the valley. So they want to go into the villages in the Black Forest. And again, this will be very similar to a living lab approach. So we will clearly install quite a few of them. Yes.
It may be an interesting way, I think, to connect the two projects, the one in France and the one in Germany. We can imagine to have some, I don't know, to reproduce some, I don't know, survey or some modeling in the various living labs. So we have another question.
Yes. Thank you so much, Marc, for this very interesting and rich presentation. I would like to come back to your slide regarding Area C, where you present the importance of integrative model framework, and you have these two-dimension space and time, and different also way and objectives of integration regarding different themes and so on. Do you think you have to identify different paths of integration, because it's a very big ambitious with two dimension, nearly 3 or 4 dimension. Do you have an idea with a 7-year period in front of you, if you have selected some pathway on these big schemes in order to gain in integration of information, knowledge, and maybe modeling?
Yes, that's a very good question. We clearly, as I said, we're not aiming at one supermodel. I think we will fail. So the path of integration would be that we look at some, this is what we are forming now, some subgroups. So we look into some mini clusters, putting together models that already run together. So I have, for example, some experiences, as I have shown you, with connecting process-based growth models with economic models. So this could be one first step of integrating the two and see how they run. Then we would like to connect the process-based growth model with a hydrological model that we also have been running now, my colleague, the hydrologist. So this, again, we have already experiences. So that would be the first, let's say, a nested modeling approach. And then the goal is indeed, when we go into the economics, we will form sort of a clusterino, a subcluster where I mean, this is new for us. We will indeed set up a market model. We need that, a partial equilibrium model. But we will link that to a model of the colleagues that look into the industry, so the industrial part. So this is resource efficiency, climate change mitigation potential of the resource. And then we will have a network of market models. And then when we see that these smaller clusters of sub-models, when they work, then we can think about, does it ever make sense to couple them to these other sub-models, or do we rather run them in parallel and make some scenario analysis, let's say moving data, output data from one subcluster to the next one, or is there even a possibility to link them together? I'm a bit skeptical on that because I've seen many of these huge models somehow failing or not being handleable anymore. But this is a bit the way of the pathway, how we try to seek this transformation, this integration part, starting with models where we know they go well together, and then see whether we can link them on a higher level. Yeah.
Merci beaucoup Marc, merci Marielle. Et effectivement, ces projets sont teintés aussi de beaucoup d'incertitudes sur la manière jusqu'où on peut aller. Et vous avez un gros challenge face à vous. En tout cas, merci d'avoir partagé ça avec nous, Marc. Et puis à bientôt pour des aventures ensemble. Merci.
Merci. Merci.